Hello everybody, let's go ahead and get going on this homework helper for 4.2. I'm going to try to jump around to some of the more tricky problems to kind of reward some of you that are watching these videos with some of the more difficult things that maybe we don't have time to cover in class. So for 4.2, what I want to do is I really want to go down to number 8 here. So let me zoom in. Okay, so number 8 is asking us if we have 1/2 y equals k, what can we do to get y by itself? I can find y by, well, we see that the coefficient is 1/2, and 1/2 is being multiplied by y. And anytime we have anything happening to the variable that we care about, we have to undo that. So for example, if we're multiplying it, to move it, we divide. If we're dividing by something, we multiply. If we're adding, we subtract. If we're subtracting, we add. If we're raising it to the second power, we take the second root. If we're rooting it, we square it, etc., etc. So these are all the things that we do. We do the opposite function to get that thing to do what we want to do. Now, what happens here is we can divide by 1/2, divide by 1/2, and so we get y equals k divided by 1/2, and this looks really weird, right? We're like, this doesn't look right. This isn't exactly what I want to be doing. And so what I really want us to remember are some of our fraction rules. And so we know that whenever we divide by a fraction, it's the same as multiplying by the reciprocal. And what's the reciprocal? Well, if a fraction is a over b, the reciprocal will be b over a. So when we're dividing by 1/2, when we're taking k and dividing by 1/2, that's the same as multiplying by the reciprocal. So that'd be the same as k times 2 over 1, or just simply k times 2, or even more simply, 2k. So that's one thing we can do. We can divide by 1/2 there to get that answer. But I want us to think about something else. If I'm taking half of y to get k, and I want to get y by itself, well, what can I multiply 1/2 by to get 1? And what I want you guys to see is whatever this denominator is, if it's 1 over it, if I multiply by 2 on both sides, well, 2 times 1/2 is a whole, right? And also, if we view it as a fraction, my 2's cancel. 2 divided by 2 is 1. 1 times 1 is 1. So y equals 2k. This, I think, is by far the easiest way to do it whenever we have a fraction, is just to multiply by the reciprocal. If reciprocal, whenever we see it. So for example, if I had like a 3/4 x equals y, or whatever, and I wanted to get x by itself, I would look at this fractional coefficient and multiply by its reciprocal. Multiply by its reciprocal. My 4's would become 1's, my 3's would become 1's, and I'd be left with x equals 4/3 y. Doesn't matter what fraction we choose. If I choose like negative 17/32, or something crazy like that, all I have to do is multiply by the reciprocal. Negative 32/17. 17's cancel, 32's cancel, and so x equals, oh, I've got to do it on this side too, negative 32/17 y. Ooh. Things to think about. All right, next, I want to go down to the set, and I want to look at number 16 here. I was helping a student with this yesterday, and I kind of want to talk about what's going on here. So we're going to kind of do this piecemeal. We're looking at 5 times 2 times h, and we've got to figure out what all these things mean. So h means, it's our only variable, time in hours to travel to school. Okay, so this is going to be measured in hours. So times to travel to school. So when I look at this expression, 5 times 2 times h, what does that mean? Well, if I'm taking the time it takes to travel to school, and I'm doubling that, well, you get to school. Is that all the commuting you do in a day? No, because when school ends, what do you got to do? You got to go home. So 2h here represents all the commuting in a day. All the commuting in a day. Yeah, both getting to school, but also getting back, right? So that's what 2H happens. That's all the commuting in a day. And that's going to happen 5 times. What happens 5 times? 5 days a week of going to school. So this whole expression, 5 times 2H, is all the hours commuting in a week. Okay, you can read that. I had to write really tiny. I don't like how this is set up. So do your best, write in the margins, do whatever you need to do to make it clear. But that's what I really want to focus on, is that this actually means something. 5 times 2H means all the commuting in a week. There, back, 5 times a week. Unless you're in no school November, when we have weird weeks like this. Okay. Next Reno. What do we got here? Okay. So I want to go to this Go, where it's giving us things in, we call this set notation. Okay. Set notation, and I'll go ahead and break this down. It explains it, but the set of x such that x is all real numbers from -2 is less than x to negative less than, or is then less than 6. So all that this means in interval notation is we're looking at all the numbers, all the real numbers between -2 and 6. We already know how to do this in interval notation. We know that -2, 6, and because it's less than, we're going to put parentheses because -2 doesn't count and 6 doesn't count. X can't be 6 because x is not less than 6. Duh. X can't be -2 because -2 is not less than -2. It's the same thing. So let's look at this one. This one goes from -4 to 7. So they're all going to start like this. The set of x such that x is the set of all real numbers such that -4 is my lowest number, 7 is my highest, but I see that I have brackets, so that means it's going to be less than or equal to, less than or equal to, whoops, less than or equal to my x right in the middle. Let's look at this next one. The set of x such that x is all real numbers, where x is greater than or equal to -9. So my lowest value is going to be -9. My highest value, well, x is all numbers that are greater than that, so my highest value is going to be infinite. Okay? And then it's or equal to, so that tells me it's a bracket. And then this is infinity, so we always put a parentheses since infinity isn't a real number. Okay? Let's look at this one. Well, it's an interval from 0 to 13, where 0 doesn't count, but 13 does. So it's the set of x's such that x is all real numbers. This always happens. We're always writing this. Where our lowest value is 0, our highest value is 13, x is in the middle, but what we see here is that because it's a parentheses, it's just going to be the less than sign, but since this is a bracket, it's going to be the less than or equals to sign. And there we go. That's how we do all of those. Next, let's go down to this section. This, I'm hoping, is review, where we're just graphing inequalities. Okay, I'll do number 27 here. X is greater than 5. Here's 5. Here's 6. Here's 4. X is greater than 5, so that's going to be an open circle. Then I'm going to shade this way and put an arrowhead on it. So that's a way of showing that x is all values greater than 5. This is greater than or equal to -9. Okay, so let's see. Here's -9. Here's -10. Here's -8. So because it's greater than or equal to, it's going to be a closed circle because 9 counts, and it's all values larger. Right? It's all going that way. Okay? This one's cool. From -7 to 0. All right. So here's -7. Here's 0. Here's all the numbers in between. I'll call this -3. Why not? So -7 is our lowest value, and it's included because it's or equals to, so I put a hard dot. And then x goes all the way up to 0, which is an open circle. So I would shade in between here. Alrighty. And so that's how we would do those. Good luck on all of this, and we'll see you tomorrow.